Let's talk about thickeners in washing processes. We use thickeners specifically, but the process of washing is overall used whenever leaching is very rapid, as with small particles containing very soluble solids, or when leaching has already been completed, may be the case, or when solids are formed by chemical reactions in the solution. Eventually, what you're going to see is that you need to wash your product. Therefore, we will have to countercurrently wash the solids to reduce the solute concentration in the liquid adhering to the solids. This can be accomplished by either gravity thickeners, which is the main scope of this video, or by centrifugal thickeners, which from now on we're going to be calling hydroclones. Okay, so for now, gravity thickeners. Note that they must be arranged for countercurrent flow of the underflows and overflows. Remember, we already saw this in the previous lectures, underflow versus overflows. Combined feed to the thickener consists of feed solids or underflow from an adjacent thickener, if we are working countercurrently, together with fresh solvent or overflow from an adjacent thickener. Essentially, this is a thickener. You got a tank, and this is the underflow versus the overflow. The overflow typically is on top. It's going to be sent forward, and the underflow will be sent backwards. The thickener must first thoroughly mix liquid and solids. Then a uniform concentration of solid in the liquid is obtained, which then must be the following product: an overflow free of solids. So once again, I can do this. Remember, the solids are mostly going to be downwards. So let's say here, these are the solids which go in underflow, and the overflow. The underflow with a high fraction of solids as possible. So this is very high in solids, this is very low with respect to solids. A thickener consists of a large diameter vessel or tank. Here we go. So this is actually a circle. Shallow tank. It doesn't necessarily have to be a very deep tank. And flat, slightly conical bottom. This is to force the solids to eventually form here and flow towards the underflow. The combined feed enters the tank near the center by means of a feed launder that discharges into a feed well. Settling and sedimentation of solid particles occur by gravity due to the solid particle density that is greater than the liquid density. Now, this is very straightforward, guys. Of course, you're going to expect the solid to go downwards because it is heavier or dense or more dense. In essence, solids flow downwards, liquids flow upwards, and therefore you get the idea of the overflow and underflows. Around the upper inner periphery of the tank, you're going to have the overflow launder or weir for continuously removing the clarified liquid. So the weir is right here at this level and will allow the overflow clarification. Solids settling to the tank bottom are moved inward towards a thick sludge discharged by a slowly rotating motor-driven rake. This is the so-called motor. It's going to be moving here. It's going to be moving like this. And I don't know if you see these guys, but it's going to move the solid. So the solid is going to eventually go towards the center and go away. Thickeners as large as 100 meters in diameter and 3.5 meters high have been constructed, which are huge. These are very common also in water processing or water treatment plants. In large thickeners, rakes revolve at about 2 RPM. Residence times of solids and liquids in a gravity thickener are often large, like hours. These are sufficient to provide adequate residence time for mass transfer and mixing when small particles are involved. So why do we take long? Because you want to force these to have the most contact between the materials.